Welcome to T2 Day 10 of Calculus. Let's review some differentiation rules. So first we have y equals a times x to the n. Keep in mind that a and n are both constants. So what that means is we're just going to bring the n to the front and reduce it by 1. So the derivative will be n times a times x to the n minus 1. What about y equals a to the x? Well, a is a constant, but now it's in the base. So now this is when we use ln of a times a to the x. And then we can use the same rule to figure out what the derivative of e to the x is. Well, that's going to be ln e times e to the x, but ln of e is just 1. So the derivative of e to the x is e to the x. Now we need to use the product rule on this one, and that's the derivative of the first times the second plus the first times the derivative of the second. Now we're going to use the quotient rule on this one. And remember, that's low d high. So low d high minus high d low all over low squared. Remember, that's low d high minus high d low over low squared. That's what you need to remember for the quotient rule. And what about here for sine and cosine? When we did our investigation, we found that the derivative of sine is indeed cosine, and the derivative of cosine is negative sine of x, sine of theta in this case. Or, excuse me, these are both x's. I'm not changing the variable, these are both x's. So the derivative of sine is cosine, and the derivative of cosine is negative sine. So what does that mean when you take the derivative of these functions? Well, f prime of x, the derivative of cosine is negative sine. This negative 3 is along for the ride. So you're doing the derivative of cosine x. I'm just doing this in long form, an extra step in there. So we negative 3 times negative sine of x. So this is going to be 3 sine of x. Something similar happens here, but we have to use the chain rule because of that 5. So y prime is going to be cosine, because that's the derivative sine, of 5x. But then you have to multiply this whole thing by 5 because of the chain rule, because the derivative of 5x is 5. And what's the derivative of negative 8? Well, it's a constant, so it's just plus 0. So the final answer here is just going to be y is equal to 5 cosine of 5x. G prime of x here, that 2 is along for the ride. The derivative of cosine is negative sine. And then you have to use the chain rule here, and the derivative of 4x is 4. So you can simplify this a little bit, end up with negative 8 sine of 4x. So again, the derivative of cosine is negative sine, and then you had to use the chain rule right here. Chain rule. Introduce some fractions. So h prime, the 5 is along for the ride. The derivative of sine is cosine, so it's cosine of 1/2 x. But then you have to multiply it by 1/2 because of the chain rule, and the derivative of 6 is just 0. So this turns into 5 over 2, 5 times 1/2, times cosine of 1/2 x. And if you can, I do prefer you write fractions like this, x over 2. That's super clear. So here we need to use the product rule. The derivative of the first is e to the x times the second, plus the first times the derivative of the second, and that's going to be negative sine of 2x. Derivative of cosine is negative sine, and then you have to multiply it by 2 because of the chain rule. You can clean that up a little bit, but I'll leave it there for now. And now we do the product rule again. And when I do this, you can treat this as the first function if you want, and this is the second function. F prime of x is going to be the derivative of the first times the second, I like writing it as x over 2, plus the first times the derivative of the second. The derivative of sine is cosine, so it's cosine of the original, x over 2, but then multiplied by 1/2 because of the chain rule. And yes, you can simplify that a little bit, but I'll leave it there for now again. So this is where we have the base being a constant. So the overall one is going to, you're going to have to use the chain rule inside there. But first, you know it's going to be ln 4 times the derivative. So ln 4 times, 4 to the 2 sine 3x. But then you have to multiply by the derivative of 2 sine 3x because of the chain rule. This is the chain rule in effect right here. So this is from the rules we had above, ln 4 times 4 to the 2 sine 3x, but now we need to multiply by the derivative here. To do this one, it's just going to be 2, derivative of sine is derivative of cosine, derivative of sine is cosine, so it's cosine 3x, but then we have to kick out a 3 because of the chain rule. So actually this is the chain rule twice. So the final answer here would be ln 4 times 4 to the 2 sine of 3x times 2 cosine 3x times 3. You can make that a 6. And again, you can group these together. Like you can multiply these together, make it a 6. But so you had to use the chain rule twice there. What about over here? You have to be really careful here. So this means sine cubed. That means sine cubed. So this is the same thing as sine of t cubed. So when you do the derivative, you're going to drop the 3 to the front and keep the original function here and make it 2. But then you're multiplying by the derivative of the inside. What's the derivative of sine? The derivative of sine is cosine t. So this is the chain rule in effect right here. It kicked out that cosine t. Here the best thing you can do is rewrite it in negative exponent form first. So this is 3 times x to the negative 4. Excuse me, haven't done the derivative yet. Now when we do the derivative, you end up with 15x squared because we dropped the 3 to the front, plus 3 times, well, the negative 4 drops down, x, subtract 1, you get to negative 5. So you could simplify this a little bit if you wanted to, be negative 12x to negative 5. And you can stop right there, that's fine. What about this? Well, you can use the product rule. So the derivative of the first is e to the x times 7 to the x. That's the first times the derivative of the first times the second, plus the first times the derivative of the second. And that's going to be ln 7 times 7 to the x. Here we have to use the quotient rule. Remember, it's low d high, so low d high. So that's going to be, low d high is 8x, minus high d low, derivative of e to the x is e to the x, all over e to the x squared. And I want you to stop there for now. It's great. Low d high minus high d low. And here, this 3 is just going to be along for the ride. So it's going to be 3 times ln e times e to the 5x plus 3 cubed. But then we have to multiply by, because of the chain rule, the derivative of 5x plus 3 cubed. Again, this is just 1. I'm doing it for over completeness there. So we still have to do this derivative, and that derivative is going to be 3, drop the 3 to the front, 5x plus 3 squared, and we multiply by the derivative of the inside. So this is because of the chain rule. And now, again, we're using the chain rule to give us the derivative of the inside is 5. So the answer here is going to be 3 e to the 5x plus 3 cubed times, and we'll combine these two, it's 15 times 5x plus 3 squared. So again, you could simplify it a little more. You can make this 45, but for now it's okay to leave it like that.